Hey students, in this video I'm going to go over how to solve more absolute value equations, but now we're going to have extraneous solutions. So an extraneous solution is basically the answers. When you get an answer from solving an equation, you're going to plug them in and check for reassurance to see if it will make it true or not. And an extraneous solution is whenever you won't have a true statement. So let me show you this example explained in steps. So we have the absolute value of 3x plus 2 equals 4x plus 5. And just like we did previously, we're going to write, this is already isolated, so we're going to proceed to writing it twice. So 3x plus 2 equals 4x plus 5, and 3x plus 2 equals negative 4x plus 5. So it equals this, positive and negative. So on this part, we just solve like if we have an equation with variables on both sides. So we just move the x to one side. So 3 minus 4 is negative 1x. And then the 2 to the other side. So negative 1x equals 3. And then we end up with dividing by negative 1. So x equals negative 3. So that's one of the solutions. And then we're going to solve this one. So on this one, you got to distribute that negative inside. So negative 4x minus 5. And then same thing, we're going to move the x to the other side. So in this case, it'll be plus 4x to cancel. And then you end up with 7x plus 2 equals negative 5. And then move the 2 to the other side by subtracting. And 7x equals negative 7. So then divide by positive 7. And x equals negative 1. So we end up with these two answers as a solution for this equation. But now we're going to plug those answers in and check. So I'm going to write absolute value of 3x plus 2 equals 4x plus 5. And I'm going to substitute for the x both of those values. So the first example will look like this. Absolute value of 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. So that's the original, and then I'm writing the answers based on, I'm writing the equations with the x's substituted with that value, and now I'm going to write them with that value. So absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. And then now we use PEMDAS and solve. So on the inside of this absolute value, 3 times negative 3 is negative 9. And then over here it's 4 times negative 3, which is negative 12. Negative 9 plus 2 is negative 7. And negative 12 plus 5 is negative 7. Absolute value of negative 7 is positive 7. And this is where you can see that they are not equal. So this is a no. Not true, not possible. Then over here, we do this, we get negative 3 plus 2. 4 times negative 1 is negative 4 plus 5. Negative 3 plus 2 is negative 1. And negative 4 plus 5 is positive 1. Absolute value of negative 1 is positive 1. So 1 does equal 1. So this is yes. This is true. This one is no. However, mathematically speaking, this should be one of the solutions. But when you plug it in and check, because there's an expression on the right side, it resulted with a negative answer. So absolute values cannot be negative answers, and that's why this is an extraneous solution. So that's what you're practicing on this paper. So the example that you have here is the one I just explained. So since negative 3 does not satisfy the original equation, negative 3 is an extraneous solution. And the only solution for the equation is this. All right, so in conclusion, an extraneous solution is an apparent solution. It seems like it's a solution, but you must reject it. So that must be rejected because it does not satisfy the original equation. In other words, when you plug it in and check, it will make it false. All right, so let's do this example right here, and then you can practice on the one on the right side. So we have absolute value of 3x. It's already isolated, so I'm going to go ahead and separate it. So 3x minus 9 equals 8x, and then 3x minus 9 equals negative 8x. So then we're going to solve. We're going to solve for x. So I'm going to move the x to the left side because that's just the way my brain works. And 3 minus 8 is negative 5. And because this cancels, you have 0. So then now I'm going to add the 9 and move it to the other side. So 5x, negative 5x equals 9. Then we divide by negative 5. So x equals negative 9/5. On this side, we have negative times 8x. So that's going to be 3x minus 9 equals negative 8x. And then I'm going to move the x's to the left side by adding 8x to cancel that. So that's 11x minus 9 equals 0. Then we add 9. And 11x equals 9. So I'm going to divide by 11, and x equals 9 over 11. So these two are the solutions that you have, and you can always plug them in by hand. So basically, you copy the absolute value, and then you're going to substitute these x values in here. So I'm just going to write the solution negative 9 over 5 and 9 over 11 as the two solutions we calculated. So if I plug them in here for the x, it will look like this. Absolute value of 3 times negative 9/5 minus 9 equals 8 times negative 9 over 5. Then the other one will be absolute value of 3 times 9 over 11 minus 9 equals 8 times 9 over 11. And of course, many of you rather not do this by hand. So I'm just going to type this in the calculator so you can see. Absolute value of 3 times negative 9 over 5 minus 9, and then equals 8 times negative 9 over 5. And that is a false. So this is a false, meaning that this solution cannot make it true. So this is not a solution. And now I'm going to copy down this one. So absolute value of 3 times 9/11 minus 9. Keep it inside the absolute value. Equals 8 times 9 over 11. And that one's true. So this one was proven to be true, and this one was proven to be false. So negative 9/5 is your extraneous solution. And then this is the solution. Okay, hope this video helps you understand how to identify extraneous solutions.